All right, take it away, Sandeep.
Cool. Thanks, guys. Thanks, Erin. And as Erin was mentioning, we today's session is about data sourcing and exploration. This is like a build up on what we discussed last time. Hopefully, you guys were there, and if not, we do have a like a slide deck outside and the YouTube video that Erin posted from last session. So feel free to go and take a look at that. Not sure if I can bring it up. Basically, no, it's not there. Yeah. So basically, today we are going to talk about how to source data from different places, and once you have some kind of data set, how to do some kind of exploration on it. So let's go. So for to get any kind of exploration started on any data set that get any kind of practice started from on your own behalf, you need to have some kind of data set. And now, as we all know, data is all around us, but eventually, where do you get the data from? So there are some sources which are very reliable and very user friendly to consume data from. And at the end, it depends upon what kind of data you're looking for, and sometimes you need to do some Google searches where that data set could be found. Sometimes you even need to scrape that data directly off of a website, which is not generally recommended, but few times we have to do that as well. But at the same time, there are some like user friendly places where one can go and find some exciting data sets. The most popular that we know of is Kaggle. Everybody who is into any kind of data analytics or data analyst activities, they are aware of what Kaggle is. You can find your data sets there, you can find tutorials there, and all sort of other things. Today, we are actually going to take a data set from Kaggle and going to explore further into that. Few other examples like Government of Canada Infobase. If you guys have any kind of want to see how Government of Canada is implementing their policy, what new numbers they are producing, this would be one link. Then 538 is the other. University of California Irvine machine learning repository is one of the other. There is Google dataset search. It is basically like a Google for data sets. So you can search any kind of data set you want: healthcare, biometric data, or some kind of like marketing data, or any of that sort. And then similar to Government of Canada, there's a US federal government open data as well. So they, whatever the state agencies or different data sets that they have from different states or different activities, they publish it there free of cost for you guys to share. So you can pick up data set from any of this. It could come in different form: CSV, TXT form, could be in JSON files, could be like an API connection. There are different ways in which you can find these. Today, most of these websites allow you to download CSV files, as mentioned, and based on that CSV file, once you have a data set, then you can start your journey into data exploration. So this was just a very foundation about how to source your data and where to get your data from. And next, we're going to jump on the exploratory data analysis. So once you have a data set, what do you do with that? You can't just, start uh, making machine learning models. You can't just start creating reports out of that data, right? You need to first download it. You need to first understand how this download data set looks like. What are the columns in there? Are those columns having any null values that are going to alter your affect your result? Or what kind of data set it is? Basically get the feel of it, if you will. So here are a few points regarding that: uncovering the data structure and to determine how it is coded, inspecting and getting to know the data by different methods. One is summarizing and visualizing it. Obviously, once, let's say if you have like a when we're talking about a data set, it is usually like 100,000 rows. You can't just take a look at the 100,000 rows together, but there are ways that you can get to know this data set by summarizing and visualizing it. It also helps you in detecting the outliers, if there are any missing data, if there are any anomalies that could skew your results in any particular direction. And then based on, once you are aware about how there are some issues with your data, then you can try how to address those issues. And then it also helps you in understanding like new avenues for analysis or further research if you're very familiar with the data. It also helps in preparing a model for model building and for analysis, by checking your assumptions, by selecting certain features from your data. When I say features, it's like basically, columns, or any new features that you might add into your data set. Or think about choosing the appropriate method to maybe look into a particular column. If it's a numerical column, you would look at it in a certain way. If it's a string column, you would look at it in a certain way. We will talk about all these in future slides, but this is just the very high level understanding of that. And before, as I mentioned, you won't just start doing any analysis. Before diving into any formal analysis, you will perform some initial investigations using exploratory data analysis, so that you can get familiar with the data set. And statistics and visualizations helps in condensing information, as I was mentioning. Okay. So there are a few different techniques with which you do the exploratory data analysis. First one is data inspection. There are different functions or logics or ways that you can inspect data. Then there is numerical summarization. All those numerical columns that you have, you would want to summarize them, see what their min, max, median, mean, all that other stuff that a numerical column could produce. You would want to look at those before diving into any of the formal analysis. And then data visualization, picturizing data so that you can compare how counts are differing for each category, or counts are differing from each state, or that kind of information. And don't think that EDA is like a one-time thing, that once you get a data set, you perform an initial EDA and that's it. EDA is like a cyclical process, because once you get a data set, you won't just use all of those columns. Sometimes you crunch data and you add new columns and you transpose it in a certain way, you push it somewhere else, or you ingest a new data. Now you want to combine both these data sets and see how, if you can produce a new report kind of thing. So every time you're using this, every time you're combining data or slicing and dicing data, think of EDA as like a very important tool in your pocket as a data analyst, scientist, engineer, whatever it may be. That you can, you should always be like learning more about your data, and EDA seems like a very appropriate process. And that's why it is a cyclical process rather than like a one-time ad hoc process. So every time you move data to a different stages, you do some EDA just to make sure that the data is looking correct. And whenever we are exploring any kind of data set, always question your assumptions. Don't assume anything, but look at it, query the data and understand whether your assumptions are correct. And then if you find anything fishy or something interesting, then try to dig deeper and see why that particular trend or why that particular anomaly has been happening. So there are two different kinds of processes. One is univariate summaries. That means you are going to explore each variable separately. And I think there are a few other summaries here as well. If I remember correctly, one is bivariate summaries. That means you will be exploring two variables together, like as against each other. And then I think there's also, and Erin, correct me if I'm wrong, or others, there's also multivariate summaries as well, where you can explore multiple variables against each other. So is that correct, Erin?
Yeah, I think the easiest way to explore multiple variables against each other is to like conduct a correlation analysis, where you can say generate a heat map, and It will allow you to visualize the strength of correlation between different variables, or you can generate other types of visualizations that will allow you to graph 3, sometimes 4 different types of variables together at the same time so that you can view their relationships.
Yeah. So there are different ways that you can, explore your variables by themselves, with combination of one other variable or with combination of multiple variables. I think most of the things that we will cover today are going to be univariate and bivariate. I don't think we have any multivariate query put together, but in future we will be exploring those functions as well. So when we talk about variates or variables, what those are actually. So variables could be of two different types. One is quantitative or numerical, such as your units, your cost, your scores, and the others could be categorical or discrete. That means not the numerical type, but the categorical type: product types, state, country, city, gender, etc. So this was just a very basic understanding of what EDA is and how to source data. Now we're gonna jump on to these different uh, features that we discussed: inspection, numerical summarization, visualization. And we have this data set, the Kaggle data set. If you guys want to take a follow along, feel free to. I will drop this link in the chat for everyone. Feel free to open this link, and basically once you open this up, you will land in on this page on Kaggle, which is data scientist salary. By the way, if you are on Kaggle and you want to explore other data sets, there is this section, data sets. Once you go there, there's like a whole plethora of data sets there. So feel free to pick whatever interests you more and then explore. So this is one of the data set we are exploring today. Data science job cleaned for data analysis and modeling. If you look at it, it is basically for somebody has scraped this data from Glassdoor. After scraping data, they have removed duplicates, rows, and the final result is only 742 records. These are different contents or different columns, if you will, of in the data set, and some few other words from the person who provided this. And if you scroll to the bottom or towards the middle of the page, I guess, you will see these details about dataset, which tells you a little bit more, like what different columns are, what are the different values in there, their percentage, like occurrence in a particular column. And for numerical columns, like over here, as I was mentioning here, that we have quantitative and categorical. This is a very good example of quantitative and categorical. These salary estimates are, you can think of, actually, this is not a good example, but maybe this one over here. This could this be considered as quantitative? Actually, you know what? There are 10 to, let's see. Oh yeah, by the way, there are 42 columns, and earlier it was showing only 10, but you can change the number of columns. So if we scroll to the right, hopefully this one, yeah, lower salary, upper salary. These are the kind of columns or features that you can think of as numerical. And then over here, like, industry, sector, type of ownership. These are the kind of things that you can think of as categorical values. So this is the data set that we are going to use today for our analysis. Feel free to follow along by downloading the data set or using the data set, whichever way you want. Actually, if you want to use Kaggle, then Kaggle offers a notebook feature as well, which you can use. So you just need to click on download data first. So it will download data not in your local, but in your, like, you can think of it as a Kaggle environment. And then if you click on new notebook, you will be able to access this data set in that new notebook. So feel free to give that a spin on your end today or whenever you guys get a chance. But that is one very easy way to start exploring your data set. And that is exactly what we did today. Once you set up your new notebook, you will have something like this, it'll be like unnamed or something. You can name this up. And then if you guys are familiar with Jupyter Notebook, this is a very similar kind of interface but it's just ready to use. You don't have to install anything, or that's all. Okay, so let us know if anybody is trying to try this data set on their own and is having any difficulty. Maybe we can look at that. But in the meanwhile, we will move along to the next step. So the very first step in the data analysis or the exploration is the initial data inspection. We have a chat. Give me 1 second. Just 1 second. Importing into. Oh, sweet. Laura is importing it into VS Code. That's awesome. So Laura, let us know if you have any, or if you want us to continue, or shall we wait for you? But let's wait something. No, go on. Sorry. Okay, cool. Sounds good. All right. So initial data inspection. Basically, you're at this stage, you're just trying to get a feel of data, like what kind of rows and columns, what kind of data set is in each of the columns and stuff like that. So we have a few different functions here. Whenever it says df, that is just the data frame. And if you guys are familiar with pandas library for Python, any CSV file that you have, you can basically convert it into a data frame. And I'll tell you like very briefly how we did that. But once you have a data frame, you can run all these different functions on it. One is head, which shows you first 5 rows. Info, which shows you the column names, the number of non-null values, and the types of or the data type of each column. df shape, which tells you how many rows and columns are there. Once we will do the demo, you guys will be able to understand it better. But let's just go through them now. Then the length shows you the number of columns and the number of rows respectively. Length df columns shows you the number of columns that you have, and the length of df or data frame would show you the how many number of rows you have in the data frame. Data frame describe, when you use include all, gives you the descriptive statistics for each column. And you will see we have 2 other examples. You can use include numeric, I guess, and you would have the descriptive statistics only for the numerical values. And or you can use the include object, and it would give you the descriptive statistics for each column, which is object type only. We will see in the demo a small glimpse of that as well. How to find the non-null values, data frame dot not null, and that would give you the non-null values. How to list the unique values and count unique columns in each data set. If you need to just list the unique columns, if you just need to, not the unique columns, actually the values inside a column. I think that's what I was trying to say. Unique values, right, Erin? It should be the df unique just tells you the unique values in the column, right?
Yes.
Yeah, okay, cool. And then n unique tells you like how many instances of those unique values are in a particular column. There's another way to tell if there are any columns which have any kind of missing data. So that is what you can do with df is null any. And then there is this one simple command that tells you if you just want to look at what are the different data types for each column. So with that, I think let's jump on to the demo. This is what we are going to do. We are going to jump back and forth between the slide and the demo so that we can experiment side by side. So whenever this is just on the Kaggle environment. If you're trying this on Kaggle environment, as soon as you create a new notebook, this first piece of code is already written for you. you have to run this code in order to start the rest of the process. So first of all, we'll go ahead and run this. And as you can see, they mentioned that you can write up to 20 GB of data to current directory. So that means you can have 20 GB of data set inside Kaggle, and you can do as much analysis as you want. 20 GB is a lot of data. So, okay, what this does, first one, I have 3 different data sets. We are going to look at this one today, but basically it just tells me what are the different data sets that I have in my input folder. So now we are going to use this data set. We have created data frame salary using this command pd-read csv, very simple, using the CSV file. Once we have the CSV file, we are going to replace all the negative ones, because once you have actually, you know what, sorry, let me say it again. So first of all, you create a data frame, and then I think you would want to use this over here once, just to get the feel of what data set is. So let's see, I'm gonna cancel these guys. So over here, you see that, you know, it gives you first 5 rows, 42 columns. This is the kind of data set it looks like, and all of that other jazz along with it. And then now that we know this is how a data set looks like, we know that there are some of the values which are -1, -1 in there. Erin, do you want to help me here? How did you find this? How did you start with this?
Yeah, so in the documentation on the page
Oh,
for the website, yeah, it says any -1 value means the information is not available or the scraping failed.
okay, cool.
So any value that was -1 was just replaced with NA.
Okay, cool. That's it.
And then some values within the data set were NA anyway. And so we used a regular expression here, which is short for, the short form is regex, to replace anything that ends with NA with like basically NA, so that all of the NAs in the data set, no matter how they're encoded, will all be encoded in a uniform way. So by np.nan. NP just stands for NumPy. It's just a sort of it's a Python library for dealing with math and linear algebra, and it's just a clean way to encode all of the NAs in exactly the same way, so that you know how to identify them when you're doing more analyses later on.
Thanks, Erin. Thanks for explaining that. Okay, so we know why we did the -1 and the NA replacement. Eventually, once you run this, if you want to run the entire cell, you basically just need to click on this place sign in front of that, and it would execute all of that. And this is like a little bit cleansed data set with all the basic cleansing that Erin mentioned, just that. So we were looking at these different columns. Head, we understood what that is. Let's look at the info and shape. So this is the info. Now that salary is our data frame, and then we're going to look at the info. It just tells you the different columns. How many columns are there? Be mindful, it starts with 0. So the total number of columns are 42, not 41. Different number of values that are populated for each of the column, whether that column is null or not null, and the data type for each of them, each of the column. So you can see there are some integers, there are some objects, floats, and basically just those. The other thing, it also tells you a little little bit more information here, that it has 742 entries. It starts from 0, goes to 741. It has total of 42 columns. So basically same thing that we just read. 3 different data types are available here, and this uses total memory of 243.6 KB. So just like very basic information it gives you. So that is going to be the info. This just tells you about, what kind of data set are we dealing with. And then comes the shape. The shape is just another thing. It tells you that there are 740 rows and 42 columns. It just basically doesn't give you any information. It just tells you the shape of the data set. Then there are a few other things which are length and length df describe. We will cover a few of these, but if you want to talk about let's say length of sorry length of the sorry not df, salary is our data frame. So it tells you how many number of rows are there. So there are different ways to get to the same information, but obviously some if you use salary shape or data frame dot shape, then you would need to extract the value out of that. This just gives you the value of how many records are there. And then I think if we do columns, yes, if we do columns, then that would give you the number of columns here. So just a different way of doing same thing. Then comes your describe all, not null, unique and stuff. If we go to describe all, this is one of the columns. This is the one of the function. When you use salary.describe include all, it includes all the columns that you have. It has, okay, maybe this is one thing that I also need to check. And do you know why? No, I think there are 42 columns. Earlier it was showing 33 columns. So I don't know why that was for. But it shows you all the columns, 42 columns, and then different, information about those columns, count of records in each column, unique records in each column, top, frequency, what is the frequency, mean, standard deviation, and all this other stuff related to it. So this gives you a little bit more information about this data set. So by now you can see that, just by running these few basic queries, we were able to understand a lot more about our data set that we are dealing with. And then there are a few like data types. That is another thing. So basically whatever we saw here, these guys, these are the data types, integer, objects and stuff. And there is another command for the same thing over here. It would just tell you same column names, but just the data types. So depending upon what what is the information that you're looking for, or if you will need to use that information somewhere else, you would run that specific command. Okay, so, and we will cover this not null, is null, unique, and unique in a while. I can show you this is null any. It doesn't provide a lot of information, honestly, but it just tells you that whether, yeah, over here, it just tells you whether any of the column has any null values at all. So that means index doesn't have a null value. Salary estimate doesn't have a null value, but rating has a few null values. Founded has a few null values. So it's just the Boolean information that it provides you. So again, not a lot of description here, but something to be mindful of if needed. Okay. So with that, we are going to go ahead to the next slide. So this was just the initial inspection. Now that you're familiar with, what kind of data set you're dealing with, you would want to get the what is called the central tendency for quantitative data. This, just think of it as all this information that we found in the describe, which is mean, standard deviation, min, max, 25 percentile, 50, 75 percentile, all of this information. You can see it all at once, but how do you query this information out of this? You would need to write a lot of code to get this information out of this. And honestly, I think there is a better way to do the same. Let's say if you're interested in one particular column, you can look for um, you can look for that particular column and see. Oh, sorry, give me 1 second. So let's say if you're looking for just mean of this one particular column, average salary. By the way, this data set, the one thing that we noticed when we were talking about this is it has spaces in between. So because it has spaces, this is one way that you can write it. If I would have been just looking at rating, then the other way I could have done this is salary dot rating dot mean, like that. So it would give you, I mean, this is could be confusing, but this is just the rating mean piece running. And if you have like spaces or anything else in your column names, then you would might want to put the column names like this in square brackets and in the inverted commas. So this one would be, if you can see, 101. Now, if we look at average salary, like we did describe, and for the average salary, the mean comes out to be 101.48. And if you run the same, you get the same value. But this is much easier to pull out or use in your function, use in your code any way you want, rather than pulling information out of this whole data set that you have. By the way, I did mention that when we were talking about this, in addition to include all, there are a few other ways that you can describe the data set. And that is, one way is this, include only the number column. So just the number numerical columns are used in this. Yes, this is just the numerical columns are used in this and not the categorical columns. And at the same time, I think Aaron had one more. Yeah, just this one is just for the object. When we say object, only the categorical columns. So these ones, so you see when you have the numerical analysis, you get count, mean, standard deviation, and all this other stuff. But when you have the categorical information, you basically get just not much information. But that makes more sense. For categorical, you will not get min, max, and all this other stuff. All right. So with that, we were covering this piece over here, min, median, and mode, and trimmed mean. So we'll just quickly talk about what mean is. Everybody knows, almost everybody knows that it is the average value of the variable. So that means sum of all values divided by the number of values. Very simple code to calculate this. Data frame dot column name dot mean, and bracket start and close. Same for median, the middle value of the variable when sorted, and mode is the most frequent value of the variable. Trimmed mean is when you want to exclude X% of the lowest and highest data points. And this is the code for that. We will run it in a while. Basically, if you're trying to remove 10% of the lowest and highest numbers, you would have proportion to cut 0.1. If you are trying to exclude, let's say 25%, you would have 0.25. So that should give you the idea how to trim the mean. But if we take them one by one, this is the, so by the way, I'm taking average salary as an example column, but you can use it any numerical column here. Average salary mean I calculated. Then if you want to calculate mode, same thing, just mode here at the end. For median, you would just calculate just the median function, and this is your trimmed mean. So I am cutting 10% from the top and bottom of the data set, and that is what my number comes in. Now let's say if I change it to 25%, I'm cutting 25% data from top and bottom. Average changes a little bit. Now it is 97%. So this is one thing that you can do. If you need to compare, let's say mean of two values, you calculate mean of one column, and then you calculate mean of another column. You can find differences between them. I mean, it is just an example, basically, just to tell you that there is a way that you can calculate a particular column's different tendencies, central tendencies. Okay. I'm talking for a while. I'm just going to pause for one quick second and see if anybody has any questions about what we discussed so far. I hope you guys are able to follow along, and let me know if we need to repeat anything for you guys. Okay. So the next one, now we have found the central tendency. The next one that we need to find is the spread of the quantitative data, like how much your quantitative data is spread out. So this tells you the amount of variability that happens inside a quantitative column or information, and it provides you the context for measures of central tendencies. So you have covered, you have calculated the central tendencies, but it just provides you more context about your data, if you will. Few things that we can calculate are range and difference between the maximum and minimum values of a particular variable, interquartile range, difference between the 75th percentile and the 25th percentile values. There are two different ways to calculate this. One is using pandas, and the other one is using scipy.stats. Then if you want to calculate variance, square distance from each data point to the mean, this is how you define variance. That's very simple function, just like we discussed earlier. Square root of variance would be your standard deviation. Again, just data frame, column, and std. Mean absolute deviation is the distance between each data point and mean. So variance was the average of square distance, and the mean absolute deviation is the mean absolute value of distance between each data point and the mean. Okay, cool. And again, very simple function for that too. So now let's see if we run these, how would these run? So we will, I could have started from the bottom as well. But hey, range, if we want to calculate range of it, it is 238.5. We got the max of it, got the min of it, and then subtracted both of them. Interquartile range, if you want to calculate this, this is just this is one of the simple method from scipy.stats, import IQR, interquartile range, and then IQR in brackets, you just have the data frame and the column name. If you want to calculate variance, simple, data frame, column, and var. For standard deviation, std at the end, and for the mean absolute deviation, it'll be mad at the end.
So I just want to hop in here for one quick second because I think that what many people could be thinking, at least what I think automatically when I sit through a presentation about statistics and like how to find out different values like the variance and the interquartile range, I think, why do I have to do this? Why are we going over this? The answer is that there are really good reasons to find out these facts about your data. Because if your data is, say, skewed one way or another, or if it's not, like if it doesn't follow a standard distribution, or if it's got outliers, that's going to affect how you need to process the data in order to perform machine learning. And it's also going to affect the types of hypothesis tests that you need to run in order to answer your questions, like if or sort of prove or disprove your scientific or business hypotheses. So there are good reasons to go through all of these, and we'll get into how these functions will be very applicable, probably in the next meetup that we do. But for now, just trust us that it is important to know these things about your data before you try to do any modeling or machine learning.
So that, yeah, statistics is not, even I don't like statistics, but just to get familiar with data set or just to uh, work with data, you need to learn a little bit of that. So it is boring. I understand that, but as Erin mentioned, there's a reason behind that, and we will uncover that in the next meetup. So thanks, Erin. All right. So this was just like a basic information on how to go around with the quantitative data. So now let's move on to not boring. Okay, that's good, Laura. That's great that you don't find it boring. That's awesome. Now let's move on to categorical data. So categorical data, as I mentioned, could be of types, any kind of categories, state, countries, and stuff like that, job titles, etc. So it is just a good way to get the initial impression of data and generate like a frequency table. The one function that you can use for that is df dataframe.column.value counts. It tells you how many values are there for each of the column, if you will. And I am not sure if there's any particular code for that we have written, but we can always.
There's a loop
Here's the loop.
further
Here's a loop.
where you go through, it will go through all of, yeah, that one.
So basically, this is what Erin wrote, and I wasn't aware of this either, but this is pretty cool. So she wrote a for loop here where she's including all the attributes that are of object type, and then finding each value in that, how many counts of those values are in a particular column. Did I explain that right, Erin?
Yep,
Okay.
that's
Okay.
right.
Yeah, okay. It's a little cumbersome to understand, but basically what she's doing is, if you have one column, let's say this one, headquarters. In headquarters, we have these different values, New York, etc., etc. And this is telling you how many times have New York occurred in that particular column. And then same for size, the size of company, I guess that's what it is. How many times the size of company was 1,001 to 5,000. That's what we are looking for. So very descriptive. You can look at all of this. Yet, we have in this data set, most of the companies that we have are from the biotech and pharmaceuticals. So that is one way that you can use the value counts. And then value proportions, useful to check proportion of value in each category. I don't think we have any code for that though there. And
I don't think so, but basically what you would do is if you look at if you do value counts for a single column, you would then divide that by the length of the data frame, and then you would get a proportion.
The value counts. And then you divide it by length of the entire data set.
Yeah.
Okay. And that's it. Yeah. Okay. Do we need to normalize it or something?
Well, I mean, here you're assuming that all of the headquarters, like there is an entry for all of the headquarters, like for headquarters in every row, which may not be the case. There may be some NAs, but no. So there was a question about what is normalization. And normalization is a procedure where you adjust data so that when you have, say, two columns where in one column the values range from 1 to 5, and then in another column, the values range from 1 to 3,000. You need to find a way to scale them so that they're comparable. Because if you compare them directly, it's not going to make much sense statistically. Just comparing values from 1 to 5 to values in 1 to 3,000. So that is something that we will cover in the next meetup as well. And normalization is a key step towards preparing your data for machine learning and modeling.
Thank
No
you, Erin.
problem.
Okay, cool. And then I think we already covered this df.describe include object. We can go through that again. I think it was here. Yeah, it just tells you the 4 basic features of the data set: count, unique, how many are unique, what are the top, and the frequency for all the descriptive attributes or columns. Okay, so that was our categorical data set. And then once you have done, this analysis of quantitative versus categorical, next thing would be to look at your data in a visual manner and see if you can figure out a few things from that perspective. So for that, there are 4 different ways. Honestly, there are multiple different ways. We are just capturing 4 here, but we will leave the rest for you guys to explore. But one way is that you can design histograms for quantitative data, and we will see how that is designed, but this is like a very basic code for that. You can design box plot for quantitative data, and for categorical, you can use either count plot or pie chart. So let's see what those are. So this one over here, this one over here, we have a histogram plot. You use the SNS library, which is a Seaborn library, and then sns.histplot. Your data is like the argument that you're looking for. You provide your data set here. X is the, I think whatever the description on x-axis, and how many bins you want. So once you provide all of that, then Erin has also mentioned the title of this data set, which will be printed on top. And then you can do plt.show. And I think there's, oh yeah, this is one new thing that she has actually pointed out the mean of this particular column and marked that as a black line over here. So I think, Erin, this is, and the mean we know from here is 108 or something, if I'm not wrong. Yeah, mean of this one was 101, sorry, my bad, 101. And that is why it is super close to 100 here, which is pretty cool. I was, this is new for me as well. Thank you, Erin. And then the next one is count plot. I don't think we have a code for box plot here, but yeah, we have count plot. So we are looking at the size of the companies, what the employee strength of that company is, and then producing a count plot for that. So you can see on the x-axis we have size 500 to 1,000, 10,000 plus, and how many number of companies or records, actually, yeah, companies we have in the which have that particular size. So as you can see, the highest number of companies, this, by looking at this, you can tell that most of the companies have 1,000 to 5,000 employees, but there are very less companies, obviously, which makes sense. There are very few startups. And then as you go along, this is like the most common number of employees in each company. And then there are almost the same number of companies that have either 500 to 1,000 or 10,000 plus. So this is what I was mentioning earlier, that by looking at this, your data visually, you will be able to understand it much more clearly. And then obviously you can use any other column here, and then it would produce metrics accordingly. And then towards the end, we have the pie chart. For pie chart, we had like very small values, so I had to expand it to like quite a big size as compared to the other visuals, as you can see. But it tells you, what is the breakdown for each of the job description. As you can see, most of the job descriptions are for data scientists, and then the next ones are for, you can say, other scientists, and then data engineer and analyst, and then there's small breakdown for the other categories. So this tells you, a little bit more about your data. And similarly, you can just keep exploring. We could have added few more codes here, do box plot or heat plots, I guess that's what they're called. And there's distribution charts that you can do. There's something called violent chart that you can build. So all those cool things that you can do with just with few of these libraries that we imported at the top here, just like NumPy, Matplotlib, Pandas, and Seaborn. Just with that, we were able to find so much about our data set. So yeah, so basically that is it towards the end of it. So we covered what are the initial data inspections are, central tendencies for quantitative data, spread, and then how to look at categorical data, and then the visualization. So that marks the end of the demo and the presentation. But if you guys have any question, we can take that right now. And if you have any comments, we can discuss about that. Feel free to unmute yourself. Sorry, what was count plot? So count plot was this one. Count plot was just counts of the different values in a column mapped against each other. Cool. So yeah, sure, no worries. So let us know if you have any questions. Otherwise, I would suggest that you can use this particular data set, which is data scientist library, or as I mentioned, go to data sets. And as you can see, there are like gazillion of them. Whichever else you want, latest laptop price, and whatever else interests you, you can search for your own. There's music database, there's Solana NFT collections if anybody's interested in that. So all those sort of things. So as I say, world is your oyster. Go out and explore. Hopefully whatever we discussed today would help you. Again, this is not this doesn't cover the entire exploratory data analysis piece, but this gives you the basic understanding how to think about a data set, and how to start getting your hands dirty with it. And this piece that Kaggle provides of creating your own notebook, and you can include 20 GB of data in that, is super impressive. So please make use of that. And if you have done any analysis, feel free to let us know, so that if you want to share that with the world, and we can also keep a demo session or keep a Zoom session for that too. So with that, I will stop. And Erin, if you have anything else to add, feel free. Or if anybody else has any questions, feel free to ask those.
So if anybody does have questions that they think of later on, feel free to post them on the chapter Discord server, and we will answer them. I will put up a link to the recording of this session, and also a link to the slides tomorrow. And that will be on the Discord server and also on the page for this meetup. So you can look at it afterwards if you're interested in any of the links. or any of the functions that we described.
And that's awesome and great, Laura. Glad you had fun. The other thing that we would also like to mention is that this data set that we have picked up together for data scientist salary that we have got from Kaggle, we are actually going to just keep on exploring on this data set for the rest of the sessions that we are coming up. We will take this particular data set to build a machine learning model, to do further kind of analysis. So if you're excited and you would like to learn more about that, feel free to join us on the next sessions. We'll have monthly sessions on different topics of data analytics and data science for a few more months. And as I mentioned, if you have anything else that you want to show, not exactly related to data science or data analytics, something of web app that you have created, let us know, and we would love to have you showcase that to the world as well. Cool. All right, I think we're good.
Great.
I'm going to stop the share, and you can also stop the recording if you want.
All